I'm going to walk through the full knowledge lifecycle with Sphinx, from uploading information, having Sphinx distill and learn from it and add it to a structured graph-based knowledge base, and then the deployment of that information into your AI agents to improve accuracy, efficiency, and repeatability of results. So we'll start with a somewhat populated knowledge base corresponding to a bank. This is all synthetic data, but of course you can see that this bank uses, for example, Snowflake. They have tables corresponding to the products they offer, the instruments they're trading, different risk metrics, etc. All partially documented here in the existing knowledge base. And we'll go to add some new knowledge into the system. We'll just upload some documents we have, and these are SQL queries corresponding to some of the dashboards that have been implemented in this bank. We don't need well-formed knowledge. It can just be whatever it is. So we upload around 70 files of the SQL queries. You can see some examples of what these look like here. There are some that are measuring, for example, ESG violations. There are some that are measuring things like which client concentration in single funds, various different metrics. And effectively what Sphinx is going to do here is learn from each of these what are the pieces of idiosyncratic business knowledge that each query encodes. So queries may have some stuff that's quite generic, for example, doing regression analysis, aggregation, basic SQL knowledge. That all, of course, your AI systems will already know how to do. We will specifically isolate, extract, and ingest the idiosyncratic business-specific knowledge of how you define metrics, of how knowledge is used to make decisions, of how knowledge is displayed and information and data makes its way down to stakeholders, and put that into the knowledge base so that you have a much clearer way of augmenting agents. So as you can see here, this job is running, taking each of these pieces of information in turn in parallel and using them to build more knowledge. And of course, these jobs are designed to be quite robust to standard kinds of errors. So even if something happens not to work, in this case, it seems like the LLM-based summarization of some of the findings failed, we can recover from that quite easily, and the model will backtrack and figure that out. So now with this ready, we can effectively open a pull request-like object for review so that a human, a data expert perhaps, can come in and see what changes were made by this process. So we'll click open pull request. And looking here, you can see that there are various changes that have been made. We can, pages documenting different tables, and we can click through and see what actually has happened. We've added business interpretations, key relationships. We can click through the graph that's been created to tie these relationships together. And now we can go in and approve this change and add it to our knowledge base. The knowledge base is now going to be updated for all users. Anyone using Sphinx will get this. So let's now jump into Claude. And we'll ask Claude a question. And Claude is, of course, here connected to Sphinx. Can you tell me if larger or smaller clients have more ESG violations? And let's also ask for a business-friendly summary, including citations back to the knowledge base, ideally. And let's also ask for a plot so that we can see what this result looks like. Now, of course, Sphinx will get to work, or Claude will get to work, invoking Sphinx under the hood to pull in all the knowledge that it needs. This is a process that we can run from any agent, Claude, from Codex, from Cursor, from any of the tools that you might be building internally. Sphinx is available both as an API and as a MCP server. And of course here we have the plot and the analysis is complete. But more important than just the fact that we have produced an analysis, which of course agents can generally do, we're also able to say what was measured, why was it measured, right? So each client's total assets under management, when I say large client, small client, of course that's pretty vague. It's mapped to assets under management because we've documented in our documentation about our bank's clients, how to measure their size, what's an ESG violation, again, somewhat vague, but we're able to go and find that we have an ESG severity score metric, how that metric is to be computed, how it's to be joined with each of the clients. And so we cite all this information and we're able to arrive at a reasonably robust conclusion, a repeatable conclusion, of course, because if we did this again, we'd get the same sources that would tell us how to do it correctly in the context of this enterprise. Of course, these link back to the knowledge base, so we can go see what is an ESG violation severity score, documented in plain English on top, and then more technical details on the bottom, all written, of course, by the AI here in the previous step that we demonstrated. And just to kind of show the feedback loop here, of course, even non-technical users can contribute back to Sphinx. So I can say, for example, if I'm a business stakeholder, that, I don't really want things to be measured by assets under management. For this analysis, I want it to be measured by number of accounts. So go do this, update the knowledge base for me. Firing off a query like this, generally the agent will first have to do a little bit more exploration of the data to build some intuition around what it is you actually want to change. And once it's built that intuition, it can get straight to, first of all, here refreshing the result, but also now adding a job to the knowledge base to make an update. So this is now a targeted update to capture this specific piece of information that will run through the exact same knowledge distillation and update loop that we showed before. And here the context, of course, will not be those dashboards, but rather what we just did, plus the context from the user telling us what to do. A technical data owner could now come in and say, okay, this is a request that's been made, and we would like to review it as a pull request. We have a new change that's been made where we've created these metric pages to document this kind of client size, which is now measured by number of accounts, and of course ESG violations by client size. And you can see here that this page is now just one more diff. The advantage here, of course, is that everyone can contribute to the knowledge lifecycle, not just the most technical stakeholders. So everyone is able to use tools like Claude or other agentic systems to get accurate answers, to get citations to those answers, and to give back to the knowledge base so that data owners don't really have to have that constant maintenance burden of updating and keeping things live.